All right, very good. Okay, well, thank you for the introduction, Andrew, and for setting this up. I want to welcome all of you to this presentation. We're going to talk about a set of functions that we globally refer to as MY. It's applicable to the control editor, it's applicable to image focus, and it's applicable to our IP Complete offering, which is a inspection of the communication server supporting the ZOS TCP/IP stack. Now today we're going to talk about MYIFO, and we'll be together for about 30 minutes. By way of orientation, so that you know specifically what this topic is all about, let me just review how image focus performs its functions when it's running in the background or in batch. When it's running in the background, it requires a setup that is accomplished through a set of panels that are accessed through the integrity controls environment, which is a VTAM application that allows you to create a virtual sysplex, and we'll talk more about that in just a moment. For those of you that would prefer to run the image focus inspection process in batch, we offer batch programs as well, and they come in several different forms. We call them MYIFO BAT or IceBAT, IceBAT-S, and IceBAT-A. Now the basic difference between them is that when we are looking to run the background process, again set up through the VTAM application, we're naming a sysplex and we're defining to that sysplex images that we would like to have inspected. And once that inspection is complete, we would like to have a cluster created of those inspection results, and then further we would like to know whether or not those images in fact will ultimately perform as good citizens in a sysplex. So there's a sysplex inspection component that's critically important to understanding the coupling facility and the definitions in the individual images that qualify them to be a good citizen in a sysplex. So that's a unique feature of the background itself. It also creates image configuration packages, and these packages contain information that is used sequentially to determine whether or not there are any changes in an image's configuration, and that information is reported. Now this is a virtual environment, so it's actually running on a single system, but it's actually inspecting not only that system, but other systems that are within the scope of what image focus can reach at that particular moment in time, depending upon unit address and load parm defined for those images when they are set up to run as the background itself. Now, when we contrast that with IFO BAT, what we are essentially doing is running each one of these batch jobs independent of each other in order to create an inspection of image A and B and C and X and so forth and so forth. And what is now happening as part of that is that we get individual reports, inspection reports for the individual images, and then we get individual packages for each of the configurations of each of those individual images. The advantage of IFO BAT is that during its inspection process, we can actually compare on the system that it's executing on the content of 6 or 8 specific ParmLive members against the actual in-memory content that the system is operating on. We call these dynamic changes, and those dynamic changes are critically important to the future IPLs of your system, particularly if you're considering using something like IPL boost in the event that there's some sort of IPL failure need to recover quickly, knowing that the ParmLive members that are going to actually be used in the boost process are consistent with what is in memory at any point in time is a critically important thing. And so one of the advantages of running this batch process is that it allows for the determination of the differences that exist between, again, the ParmLab members and their in-memory content. Now, how we actually execute this depends on a number of different factors. We can use, of course, a job scheduler to submit this, whether you're submitting the background or whether you're submitting individual jobs, or we have our own processes of submission and also are able to submit the background process and local image functions directly from MYIFO. Now, the major function of MYIFO is to bind, in essence, these two views of the environment together and to present it in a consistent way that would allow you to quickly navigate to points of interest and resolve problems. In order to do that, we have two specific panels which can be displayed from either the ICE environment or directly under TSO-ISPF that summarize the findings of IFO's background process and also summarizes the findings of the IFO batch process. They appear the same. They're quite similar. They detail the date and the time of the cluster that was created in the case of the background, and detail the date and the time and the number of images of a pseudo cluster that was created from the images that were defined to a common HLQ. In this case, you see it up at the top of the panel in the lower section called ICE-BAT. That HLQ defines not only one image, but if it's consistently defined, will define a number of different images that can be used, their reports can be used to create this pseudo cluster or concatenation of their individual findings. Of course, from here we can access all the reports that are created by MYIFO. We can look at the findings of all of the images that are within the cluster or within the concatenated cluster. We can look at the cluster from a view perspective, and I'll show you that. And then we can look at some very interesting features which are unique to the background and to the batch process. We can look at patterns. Patterns are an interesting way in which to identify not only changes which might be taking place in the configuration, but also changes in inspection results that might be taking place from one execution to the next. Of course, the dynamic changes in the lower panel indicate those or give access to the dynamic changes that were discovered throughout all the images in the batch process. Image changes are essentially what is described there in the upper panel, a report on any changes that have occurred to any of the images that are defined in the cluster, the sysplex cluster. And then a compare function in the lower panel that allows you to compare one image defined to a common HLQ against another image so that you could compare image A to image B or whatever the case may be, however you want to mix that up. Or you can compare the current configuration to the last configuration that was used in the last inspection. Both of these, both BG and BAT, have independent health checks that look for, in the case of the background health check, specifically the cluster and how the cluster, excuse me, not the cluster, but the sysplex inspection has performed. In other words, have we a good set of images? Have they come together correctly? Will they perform correctly? Have we defined any changes in them? All that information is captured in that health check. And then another health check for BAT, which specifically focuses on dynamic changes. Now, these operate independently of each other, and so If you happen to be someone who's using the background, then typing in MYIFO BGN will get you to this panel, and you can exercise your needs from here. If you're running the batch process, no matter how many images are in that process, if you have named them consistently, then all of the images that have been inspected, no matter which systems they may be on, will have made their reports available to MyIFO for a consolidation of that information into, again, what we refer to as a pseudo cluster. Now, one of the interesting features of both of these panels is that if you notice at the very bottom, there are 10 little circles, I call them bubbles, that indicate which cluster is actually under examination. And so you not only can see the most recent cluster, in this case the newer one is 2 days old, but as you move to the right, think of that as moving back in time, you can change the cluster data set, derive from that change how old it is, and perform an inspection of its content. Again, looking at its findings or the cluster view or the patterns or the changes in the images or the health check as it would have appeared at that particular moment in time. And that applies to both the background and to batch. Now, there is another picture here that needs to be brought forward, and that's this one. And this is MYIFO. This is the gestalt, if you would, of the previous two panels that allow you not only to reach those smaller panels, but also to perform ad hoc queries against the clusters that have been created. Set up intervals when you would like your My Reports to be executed, and also potentially set up email to email those reports to you when they are completed, whether you request them daily, weekly, or monthly. All three are functional. All reports will be created and sent at the same time. So with that kind of background, let me now go directly to ISPF interface here. I can end this, close this down. So here we see two interface panels. The one on the top is the integrity controls environment. Again, this is a VTM application, and it's the common way in which people have accessed image focus reporting and findings in the past, and is still a requirement for setting up the image focus background process. But you can go to the command line here, type TSO, if I can get my fingers to work, space, dollar, command line interface, comma, MYIFO BGN, and we'll do BGN on this side. And as we do that, it will go off, retrieve the most recent cluster, figure out the last 10 clusters, position them in order for us to be able to change our cluster view. You'll notice the dates and the cluster days old changing over on the right as we move over. If a cluster is greater than 10 days old, then the age of it shows up in red, okay, just as a marker. Now we're on the TSO side, and we can go TSO, dollar, command line interface, comma, MYIFO BAT. Now the BAT processes could be running independently of each other. So you've got maybe 5 batch processes running on 5 different systems. One is running at 8 o'clock, one's running at 9, one's running here, one's running there. So what this thing first does is it goes out and checks to see if there are any new batch executions. And again, it does it for a common HLQ, in this case, IFO test.ice.a. And if it finds one, it reports that and then rebuilds the cluster that's associated with all of the images, timestamps and dates it to today's time, and positions it as the first cluster in the string of clusters, because now we have a new inspection. It doesn't know whether we have 1 or 2 or 10. It just knows that one of the 10 is now new, and because of that, it's going to create a new cluster. Now, as we go forward here, we'll see its panel appear. And so you can see the similarities between these two, okay? And as we move forward or back in time here to different clusters, now these are again pseudo clusters. They're a combination of all the reports that were produced for all of the images. There are 5 of them in this particular case. Again, we can see the dates and the times are changing. Now, in this particular instance, what's happened is that there are 5 clusters out there currently. There isn't a 6th cluster, and so when I selected it, it reported in the cluster dataset name that there is no report dataset. And then all of the little bubbles down at the bottom turned white to indicate that there are no values for it either, or for any of them either. And so all of them are now sitting in that particular condition, just to give you an indication of which of these bubbles is actually currently active. Now, if we go to this guy and we click the last bubble, we'll see that we have a cluster that's 25 days old, and clearly that may not necessarily represent a valid view of your environment today. It would represent a valid view of your environment 25 days ago, but today it might not be useful, and so you might want to begin to do your examination with the first cluster that you have here. Now, one of the things that people like to do with this is to use it as a health check. And so you can run the health check, either one of them, anytime you choose. So let's run the one that deals with the background and see essentially what it has to report. Then I'm going to page up here because it positioned us at the first error, so it's going to sort of stick our nose in that. But let me go up. So now this is what the health check would look like if we looked at it under the health checker, and we could do that. It's going to tell us what the source is. It's going to tell us how old it is. And remember, 10 days would put up a flag. It's going to give us an indication of, within this sysplex, what is the nature of the overall finding, and that's what we're going to see here. Now let me go down just a little bit. Sorry. So we can see our 5 images here, A through E, and we can also see that each one of them overall has a finding of an error. Okay, so they're not necessarily in shape to be joined up as a sysplex because they have problems. But when we look over to the right, what we're seeing here are the coupled data sets and volumes, and whether or not there is any change that has taken place in those that we should have some concern about, and are the parameters that are within those configurations, that is within the ParmLab members of the images that have been inspected, are there any issues with those? And you can see that all of them have inspected okay. So each one of them is really prepared to become a good citizen in a sysplex, but because of their errors, we need to do a bit more work. And there hasn't been any changes in the status of the coupled data sets or volumes or the parameters themselves. They have remained constant since this time. Okay. And so we know something about the overall composition of this cisplex. We've got some faulty images, but our cisplex components are in good shape. Now, as we page down, go down a little bit more here, we'll see something else that is critically important in a cisplex environment. And here we have success. This is telling us that from a naming perspective, the cisplex name that is defined in each of our images is the same. That's good news. Each of the names of the individual images is unique. That's good news. Each of the clone names that are associated with each of the images is unique. More good news. And then when we look at the primary couple data set, we see that it's the same. This is critically important for passing information one from the other. That the Steimer is the same, the GRLS is the same, that the consoles are all unique, and that the BPX PARM members are the same. That is, the environment that's going to come up that's going to support Unix and support the stacks, and all these things are the same. And if we go down a little bit further, we see something really unique. These are what we refer to as finding patterns. If we look at this, and we look at system A, we can see that the old pattern that was associated with it had this visualization, OPE, J2E, PLS, so forth and so forth. What this is composed of, what these 3 bytes are composed of, is that the first 2 represent the inspector. In this case, this is the operating system inspector. This is the JES inspector, and this is some other inspector, and so forth and so forth. This is the VTAM inspector. This is a TCP/IP inspector. And then the third bit is the overall inspection result. So in the case of the operating system, we had an error. In the case of JES, we had an error. In the case of this one, we had success. Here we had a warning, another warning, an error, and success. And so what it's attempting to do here is to let us know what it is in a very summarized form, the entity within the image itself that was under inspection that likely is the cause, in this case, of an error. Now, if this were sent out in the form of an email, let's see if I can reset this. If this was sent out in the form of an email, what you could do is you could click on this link. This is a website that has our documentation on it, and it would actually explain to somebody that might be receiving this for the first time exactly how these components function and work. And again, this is a very high-level view of the overall results of an inspection of a cisplex made up of 5 images that was performed by IFOBG. Now, if we come over, oh, and by the way, this drops into the move copy utility. So if you wanted to, you could actually take this file now that was created that contains that report, and you could move it somewhere to copy it or print it or do whatever you would like with it. Okay, so now we're back in our primary panel. Now let's move over to the other side and look at the health checker as it relates to the batch inspections. Now remember, we said that the batch inspections really had as their primary advantage this ability to perform dynamic change inspection. So let's go to that health check. Okay, so now we see, again, some problems. We would expect this to be the same because we saw some errors in all of the images on the other side. Let me go down a little bit. Now we're looking at this, and this is telling us source information. The source here is a high-level qualifier, which is IFO test.icebat-A. And defined to icebat-A are these 5 images, A, B, C, D, and E. Each of them has an error in it somewhere. Each of them has some dynamic change, which is being reported as a warning. And each of them was inspected at a different date and time. So this one was inspected on 4/13. At that time, its age is 2 days old. This guy was inspected on 4/10. The other 3 were inspected on 4/9. So as I said earlier, it looks to see whether or not any of these images has been rerun, has had a new batch execution. And if you were doing this as I think it should be done, all of them would be updating more or less at approximately the same time. And if that were the case, then you would have a current review of all of these images encapsulated in this particular health check. Now the health check is that we're running in real time. The health check that actually runs with the IBM Health Checker for ZOS is actually performing the same task, but it's doing it at whatever interval you may have set that relates to that particular health check. So now we've sort of said, okay, well, we know what we got. We know the dates and the times of them. We know the age. We pulled together our cluster. Here's the name of it. We know that that cluster is 2 days old. That 2 days is based on this age right here. And so now we're going to go down and we're going to take a look at what it discovered from a dynamic change perspective. And so when we look at it from a dynamic change perspective, what we see is, is that each of the images has perhaps had a life that's been long enough where certain dynamic updates have taken place to things like perhaps the APF list. In this case, no, that's not the case. The BPX list, no, that's not the case. But some dynamic changes to BPX PARM have taken place in images B, C, D, and E. The link list seems to be okay. The LPA list seems to be different. RNL list seems to be okay. And the system symbols haven't changed. But again, the problem here would be that if this system had to be re-IPL'd, using IPL Boost as an example, or you just simply took it down for maintenance. If you didn't reconcile these differences between what's in memory and what's in your PARMLab numbers, then when your system comes back up again, it's going to be different than the system that you originally took down. Again, if this went out as an email, you could click on this link and it would take you to a web page that would explain to someone who may not be familiar with this exactly how this all functions and works. And then again, page down, we have a similar analysis that relates to the patterns of the findings of the individual images themselves. In this case, we can see that yes, there are some changes and there is a difference here. The difference being that as we look through this, we can see that in the older inspection, Jez inspected successfully, but in this inspection, Jez inspected with an error. And so that's probably an indication that we want to go spend some more time taking a look at the details that are associated with the Jez inspection to determine whether or not there's something here that we should be looking at. So if I PF3 back, excuse me, I PF3 back, we'll flow back through the move copy utility, and again we can print, copy, and do whatever we decide we want to do with it. There are just tons of other functions here that we can deal with. Compare is one, where we can look at the patterns that exist for the individual images. gives us a clue, if you would, as to how they inspected. But we can move one of them. We can select it and move it to the upper part of the panel, and then we can select another one and actually compare the two. And then this compare function functions just like the compare functions that you normally would see in the image focus environment. So there are lots of other things here that I would love to be able to get into, but we've now gotten into our 30-minute time limit. And I want to thank you for coming out and joining us. Let me just go back here quickly, let you know that Andrew is going to send you a copy of this presentation so that you can spend some time looking at it. We have other presentations that we give regularly. Are you doing your best to secure your critical ZOS files? Are you doing your best to employ the available defenses in pursuit of cybersecurity? And then every other week, we're doing a similar discussion about the control editor because it has a comparable interface to MYIFO, which we refer to as MyTCE. So, Andrew, I'll turn it back over to you to see if we have any questions today. Thank you all for coming.